So we were telling you about superalloys, but because in superalloys we have creep and fatigue, so we defined. So superalloys are just alloys, but if they are much higher in strength, temperature resistance, creep resistance and fatigue resistance compared to normal alloys, we call them superalloys. Then there are alloys for biomedical applications. I already told you, biomedical applications where, right, we have to make an artificial knee, we have to make an artificial hip joint. So now we have to develop metals and alloys for those applications. Then there are new processing technologies. When we say processing, we are talking of manufacturing. That normally you have machining and casting and so on. But if you use technologies such as nanotechnology and powder metallurgy, then they are new manufacturing techniques. So they are also new manufacturing techniques for metals and alloys, right? So then they will be called nanomaterials and they will be called powder metals, right? So they are not new materials. It is just that they are being made by new manufacturing technologies. So these are metals and alloys. Here I am just showing you, if you can see, you can read also, but you see this is an aircraft turbine engine, and you know that this is one of the most complicated bits of engineering example that you can see. Huge amount of engineering. By the way, if you come to the university, the mechanical engineering department, then right across the mechanical engineering department there is a building in which there is a room with 2 glass doors. If you go inside, we have an example of a big aircraft engine there, so you can have a look at it and wonder of when I will be good enough as an engineer so that I can understand these things and so on. But the thing is that here we are showing you that it is an aircraft turbine engine, high temperature resistance, high heat resistance, of course, nickel base alloys, right? So these are alloys. Alloys would generally mean that they are steels and other types of alloys, but in these alloys, whether they are steels or other alloys, nickel has been added, and of course some other materials and so on have been added. And the main thing is that they have very high strength, of course, they have very high temperature resistance, and they are light because they have to fly, right? So this is a very strange composition, that you want to have a very high strength, you want to have a very high temperature resistance, but at the same time you want them to be lower in weight so that they can easily take you up and so on. So these materials require this. So these are some superalloys, for example. The next category, the next type of material, we told you metals are one type. Here you see, we are not talking of metals and go into the detail. This is the chapter of introduction. So the whole field of material science and engineering, what are the basics? So some things earlier, now we are talking of this heading, right? Types of materials. That in the whole field of material science, what are the major categories of materials? So one was metals, the other is polymers or polymeric materials. Now normal people say plastics, technical people say polymers. It means the same thing. Plastics is the more common general name of polymers. So again, don't read below. You have done it in previous chemistry and so on. Can you give me one sentence definition of what is a polymer? Metals, you understand now, right? Polymers. Don't give me names. You can give me that, oh, I know that something called PVC is a polymer. Something called polyester is a polymer. Yes, you are correct. Polyester is a polymer. PVC is a polymer. But what is a polymer? What is a polymer? Right? So yes, now you can, if you have given me the correct answer, it is good. I always ask you that, you see, when you go to any part of my lecture where I am asking you a question, you can pause your video and start thinking. That let me think and then read. Because whenever you do that, you think yourself based on your previous knowledge or general knowledge. 70%, 80% of the times you can give me the correct answer based on your thinking of your mind. So you see, then you are on, your machine is on, your brain is on, you are thinking. So therefore your understanding of the subject becomes very deep. But if you just respond to me whenever I tell you something, they say okay, yes, then that is not really there sharply in your mind. So now yes, the first sentence, long molecular chains or networks of organic materials. This is the first thing. You know that. So now yes, I remember that polymers are long chains. This is not one molecule. There are hundreds of molecules joined together. And these are organic in nature. The hydrocarbon thing is there. Mostly carbon and hydrogen is there, and then other materials are there. So yes, they are organic materials and they are long molecular chains. Second, they are mostly non-crystalline. Metals were crystalline, remember. These are mostly non-crystalline in nature. When we go back to the chapter on crystals, then we will say this is BCC, this is FCC, this is HCP. These are different types of crystal structures. But metals naturally form into crystals. Polymers naturally do not form into crystals. But when we say mostly non-crystalline, it means that sometimes even in polymers there is a chance that a small crystallinity is there, right? So this is what we are saying. Then they are bad conductors of electricity. Bad conductors of electricity. So they are very good for insulation, right? Bad conductors of electricity, so very good for insulation. Their strength and their ductility vary greatly. This is a big plus or minus. They are, first of all, not as strong as metals. They are much lower in strength. But in strength also, though they are much lower than metals, this strength varies. Similarly, ductility, how easily can you shape them into different forms, into different products. This also varies quite a bit. One of their very good properties, they have low densities. Low density, what does it mean? They are light in weight. Low density, they are light in weight. So this is very good because we usually want products to be light, right? But the bad part is they have low decomposition temperature. So you heat them a little and they melt and they chain and they decompose. So this is not very good. They have low decomposition temperatures, right? Then we can mix polymers with other polymers and get what we call blends. So we can now have different properties. There is one polymer with one good property. There is another polymer with another good property. We can make a blend of them by mixing them, not making a chemical compound. The two polymers chemically remain the same, but we mix them together and we get targeted applications. For example, they are saying elastomers. Elastomers are a type of polymer which can deform very much compared to normal other polymers. They can be blended with other plastics for improved impact strength. Impact strength is very special. We will talk about it. Now, some examples of common plastics or polymers: PVC, polyvinyl chloride, polyester, and others. And many common applications: DVDs, your fabrics and clothes, and so forth. These are all polyesters, right? Polymers. So polymers are basically organic in nature. They are long chain molecules. They are mostly non-crystalline in nature. They are bad conductors of electricity. Their strength is much lower than metals, but there is a big variation in their strength and softness or ductility. They are light in weight, but they are easily destroyed by temperature. And just like from metals we can make alloys, so from polymers we can make blends, right? Blends here is the same name as polymers there. And common ones are polyvinyl chloride, polyester, and so on. So this is the second major category of materials. Here we are just showing you, right, DVDs. DVDs are there everywhere, and DVDs are mostly, some small part can be metal, but they are plastics and polymers and so on, and we can make them of newer categories. And just like steels, right, you can make hundreds and thousands of different steels. Similarly, polymers, there are hundreds and thousands of different polymers, and they can be engineered by materials people for different properties and so on. And DVDs are one famous area which are very common. This is just one application, but millions of reals or dollars of applications around the world. Here is a very nice diagram. Of course, this is about say 10-15 years old, because the data that it is giving is until the last 10 years of the last century. But you see, here it is the year from 1970 to 1990. Here it is the cost per cubic inch, which means cost per unit volume, cost. So now this is very good diagram. Metals, materials, how they grow. Magnesium, steel, plastics, aluminums, other types of steels, zinc, yellow brass, right? As the time goes, right, then how does the cost go? Initially the cost may go very high because you are developing the material, but later on when you are developing more new materials, the cost would not go up so sharply. Of course, with time the world is going through inflation also, right? 1 real today cannot buy the same things that 1 real 20 years ago bought. So because of inflation also there is price rise, that maybe the actual cost of the material is the same, but because dollar today is not the same as dollar earlier, so whatever was available at $1 10 years ago is now available at $2. So this increase in cost over the years is because of inflation. That is one thing. But then, is this material becoming less and less in the earth? That is one thing, so its cost will go up. Or is the demand for this material increasing a lot? Because even if the material is there, but it is much more in demand, then the cost will go up. Not because the real cost has gone up, but because we can sell it at a higher price. So one thing is inflation. The money has lost its value. This is one thing. The second is the material now less and less in the world? If it is less, then it will be more costly. And the third is its demand increasing? If the demand is increasing, then so all these three factors increase the cost of different types of materials, metals and polymers and ceramics and so on, as time goes by. So this is just a very nice thing